I'm going to record to this computer. And then finally, go right here. Close this off. Okay, close this up. All right. So here we go. Tell me your thoughts and feelings about crosswords at this point. Like, other than, oh my God, it's hard. Tell me, what are you thinking? Tell me, what are we thinking for strategy? Feelings. Start with structure.
Could you explain like that association process a bit more, like how you feel with block squares?
Sure, absolutely. I'll explain the breadth first process. Absolutely. What is your question or thoughts as well, and I'll get to both of these, and then I'll make sure these both answer.
I was just thinking of the best way to do this, because I think like looking at both sides of the organizing for the one used to do it. If you could either split it up into classes, learning a really functional program, that's
Yeah, I think classes might be a solid strategy over here. So thinking about classes is definitely something to think about. Like I'm at this point where it's been functional programming. Because I'm kind of at a little bit of I've got a lot going on inside of here, and I think that cleaning this thing up is going to be a big deal. All right, let's talk about this right here. I don't want that. So one of the let me move you over here. One of the issues, one of the questions, actually, let's just copy this guy. Okay, and then I can kind of zoom this back a little bit. So the idea is like breadth first search. What am I doing with breadth first search that gets us through this thing? So the first thought is that we could have like some blocks inside of here, right? Like there could be spots that are blocked. And so our objective has to be to determine if all of these, and actually I don't like that. I'm going to block right here. I'm going to block right there. Our objective is going to be that we have to identify whether or not all these blocks are connected. So the first thought, and I don't know if you can see that super well. Maybe go with I'll go with this pen and kind of block these out, so you can sort of see that those are blocked out right there. Okay, so the idea behind the BFS is that the BFS explores neighbors, right? So it takes a neighbor and it says, what are your neighbors? And basically, starting at this first spot right here, it puts that first spot into the neighbor. And then it makes a list. And then let's call this A, right? So it puts A into that list. Let me make this pen a little bit smaller. It puts A into the list. And then it explores A. And as it explores A, it finds B and C. And it puts them in what is known as the open set over here. And the open set are things to explore. So when I call the get children or get neighbors, my goal right here on get children or get neighbors is to put additional items into this, into this open set. And then when I put items into the open set, I'm going to correspondingly put them into the closed set as well. I'm going to say, hey, B is in the open set. I need to look for your children. C is in the open set. I need to look for your children. But at the same token, in the course of exploring this guy, I know who those children are. So these guys are considered closed. These nodes are considered discovered. And so the point of the BFS is to go on this path of discovery. So if I have A over here and B and C are the children of this guy, by identifying A and B and C over here, so open set and closed set, I'm able to effectively say that, and then we would precede this as having, we would precede the closed set as having A with a parent of -1 over here, because there's there's no parent to A. But we know that these things are now connected to each other, A, B, and C, because the process of discovery of saying, hey, node with children, we can get these things. And so if I have D, E, and F over here, by going through B now, when I'm at B, when I advance over into here, I say, okay, B, who are your children? B's children become D and E, so you're now part of the open set. This advances, and now I'm going to say D's children is B, so this is D and E. D is B, and E is B as well. And so effectively, I'm building up this whole group over here. And this is just going to fill its way out and sprawl because I'm looking to see, oh, your children are going to be up here, here. Your children are going to be in these directions. Your children are going to be in these directions. And it's really just going to sprawl itself out in its entirety. So the point of doing a BFS search is to return this closed set at the end. And if we can get a closed set and identify the length of this closed set, in theory, the length of that closed set should be equal to the sum of however many spaces in this board are not hashtags, because the hashtags are not going to be discovered, right? So if I have a child over here, I don't have a child. I can't go in that direction and get a child, but I can go over here. So by not being able to get the children here, by when I ask, is this child a hashtag, that effectively blocks me off from this. I'm seeing some faces. So when I get blocked off, I have to keep looking here. This guy goes down. This will look over. So I can kind of point this. He does not go off. His go down over here. He goes down over there. So what this would look like in a kind of different sense, if I kind of get all this stuff. Actually, let's do this. So let's do a different blocking. So I have my blocks over here, block, block, and I'm going to put this guy, you guys are blocked off. And let me do a more complete block over here, right? So if I have a more complete block, what I'm going to see is that as I go through and get my children and build, this guy is in the open set, okay, closed set. When I start asking the questions, I'm not adding this node over here. I can't add this node. I can get this guy. I can get this guy. I can get this guy. But my BFS search is ultimately only going to return a closed set that is on these 6 nodes over here. And so what I can say to myself is, hey, you know what? I've got an 8x8 board, which is equal to 64 nodes. My closed set came out at a length of 6. This BFS did not discover everybody. Therefore, I have a blocking condition. I don't know if that was what you were asking, or if it just it feels, I'm getting nods. I feel like this could be helpful review anyway. Okay. More. Yes, please.
So, you said blocking condition, what exactly does that mean? Does that just mean you have to start looking from other places?
So a blocking condition, good question. So what I'm saying here is that if I have it such that these are all hashtags, this is an isolated region of the board. And if I have an isolated region of the board, this is not a valid crossword because valid crosswords cannot have isolated regions of the board.
Oh, okay. So
That's what we're trying to identify over here.
okay. And also just to confirm, like with the BFS, you would like to like a check that sees if it's like valid and continuous and you're in the process of putting in the blocking.
So the BFS is really just asking the question, hey, when I go to this child, are you a hashtag? If you are a hashtag, you do not get added to the open set. If you are anything other than the hashtag, you do get open to the open set. So if I have these hashtags over here, my BFS is going to be like, hey, are you a member of, are you a valid child? No. Okay, so you don't pass get children. Only this guy passes get children. Looking from here, looking down, are you a hashtag? You were a hashtag. Yeah, you're not about. So then I go to here next. So it's going to work its way across. It's going to be grabbing adjacent nodes. But if the value put into that node is a hashtag, that is not a child. And that is going to allow it to kind of stick to the wall. One of the terms Dr. Gabor has used is this notion of flood fill. And so you can look up flood fill as an algorithm. And that kind of goes out in lots of different directions with this as well. I'm not going to go into that at this moment, but if you want to look around, flood fill is a variant on BFS that will be to your benefit, Caleb. Where to place the blocks is an excellent question. Where do I place the blocks? Let's start here. Previously, the last class, I just arbitrarily grabbed and went through and iteratively went down the list, right? And that came out wrong. So I'm saying that if you start at the first available spot and work your way across, that is gonna backfire for you. And one of the reasons this is gonna backfire is that just working away, you're gonna create these regions over here that are too short, and that's not valid. So this is something that I kind of realized on Tuesday night, and this was a fun realization. If I've got an 8x8 board over here, what are actually the valid places at the start? Everybody can look at this and figure this out. Where can I put hashtags in this board right now? Where are the trivial answers in an 8x8 board? Yes.
It's just gasping. Yes.
Okay, so if I put something here, I know 100% this is not going to cause a problem, right? I know if I put something here, that's not going to cause a problem. If I put something here, this is going to cause a problem, right? That is problematic. I'm going to have to deal with that. But as a safe place to pick from, okay.
Yeah, why is that problematic?
Actually, if I put it here, without any other sort of doing things to it, if I just start by putting here, I have created spots that are words of length 1. So this is a vertical and that is a horizontal of length 1. And so this answers one of the questions from the autograder that I had and something bad information that I gave you guys before. This is not valid in a final board. It's not valid in the final board. We'll put it that way. Okay, that's a great question. I can't have a final board if this were like 4. I could not have a final board that looks like this because this, according to the rules, is going to be considered a word of length 1. I know that these are like passageways, but at least what I'm seeing right now, and Dr. Gabor has been absent all week, and I haven't gotten an answer to this, but what I'm finding is that this is being rejected. Does that, so this is considered word length 1, word length 1, word length 1, word length 1. This is a word length okay, that's a word length okay, but these other like that's not being treated nicely. Yes.
So just to be clear, like every single open spot in both the horizontal and vertical direction needs to have like
That is the gist that I'm getting. In the final board state, yeah, we need to have 3 spaces around it.
3 spaces around every single block.
Yes.
Oh.
Yes. Okay, so that becomes, somebody can prove me wrong, but I have yet to. I'm not sure if secondary positions in a word. So Devin, I'm going to get to your question in 1 second over here. But what I'm waiting for an answer on is something like this. Like if you have, well, like obviously a 2 is not okay, but like let's say I had something where you have a little skinny gap between like top and bottom or something like this. I don't know because this isn't the starting point of a word. Like this word can in theory go all the way down, but I still think that the auto grader is disliking this kind of stuff. Devin.
So suppose
Yes.
that like the input, it also like specifies like certain like where the blocks should be placed, or there like where the initial start. So like, suppose you start out with like three hashtags, and you have to place like a classical 12.
Mhm.
You mentioned that like the best place to put corner probably for like rest.
So that's I do want to I kind of want to get to this derivation of this algorithm. I agree. So give me 1 second with this. So yeah, the autograder absolutely could tell you that you have to put this piece inside of here. But if you put this here, what I'm finding is that if you get a spec for like a specification that says, hey, put a block right there, what you should do is you're going to need to say, oh, hey, you know what? I'm not allowed to have this one word right here. So in my input specs, if I see 1 1 over here, I'm thinking, okay, that also means this and this. And oh, by the way, because this one now has blocked off a word of length 1 over here, I should do that. So in a sense, this spec to put that one, the specification to put one piece right there, kind of in a way is a specification to put 8 blocks on the board. That's a separate problem to deal with for right now. But for me, I think that with knowing nothing else in a safely end game state, I can start over here, right? And I don't have a problem. Also, I could say that if I put a block right here, I'm going to have a word of 3. So this is a safe spot to start. I could start right here because I would have a 4 above and I would have this below. I could do the same thing symmetrically over here. I could have this above and that below. I could have this guy. And then similarly, I could do that in the middles over here. So I could say these guys, like these are basically the spots where I can safely put nodes in. I can plop a piece down in any one of these spots at the start and safely know that I'm not going to block off an end game condition. Does that make any sort of sense? Yeah.
Are you just saying that like all of those are safe spots? Because if you place in like all of those, then you'd be like having words of like 2. Are you just saying that it's like
So if any individual one, not all, if I do all of these, I have badness, right?
Yeah.
Because I've got these words of length 2. But if I do any individual one of them, if I do this one,
Yeah.
I'm going to be okay. Okay. Now, it's totally legal to start right here, but I'm just going to have to do something about it, right? I'm going to have to also do this. And I'm going to have to match this over here. So this is, again, totally legal, totally fine. But the basic reality is that as I'm looking at this, I should be able to evaluate a board and say, how do I identify this? So my question became, and I don't want to suggest that my way is the only way to do this. There are thousands of ways to do this. My way of looking at this then became to say, well, why don't I analyze the board in its entirety and make a dictionary that talks about the longest word that I could put in any given direction. So this is my strategy right now. I don't know if you want to use it or not. It seems to be kind of working for me, okay? My strategy is before I do anything else, I go through and I take a look at every single spot. So this is index 0. And at index 0, I'm going to make a little dictionary over here and I'm going to say, hey, what is the longest word that I could fit on the left of this? So what's the longest word I could fit on the left of 0? Say it again. 0. Absolutely. What's the longest word I could fit on the right of 0? 7. Okay, good. What's the longest word I could put above it? 0. The longest word I could put below? 7. Okay. Now, very good. Okay. So let me do this again. Let me go back in here. So I had 0 was 0707. Okay. Spot 1 right here. Spot 1. What's the longest word on the left? 1, 6. Underneath, above, how much above? 0 and 7. Absolutely. So what I did is I made a dictionary. I scanned the entire board and I made myself a dictionary over here that comes up with all of these things. So I'll do 2 over here just for the 2507. And then 3, 0123 is going to be 3407. Dot, dot, dot. Do you see where these numbers are coming from? This is basically an Othello search over here. This is an Othello search to kind of identify how many spots below that I have in each of these guys, right? I can go over here and I'm look this way, look this way, look that way, look that way. And then I did this, look that way, look up, look down, look that, and I did this at the start of the board, go all the way through. And so I made this dictionary. Now, looking at this very short list of this dictionary, how can I tell right away which of these spots are valid endgame spots? Looking at this, how do I know who's a valid endgame spot? Gerard.
So you know that 0 and 3 are valid spots because 1 and 2 have like a possibility of having a word of less than 1.
Less than 3? Is less than 3 the condition? You said it, you contradicted yourself with, you said the first one.
Oh, sorry. I mean, like, you just can't have a word that's length 1 or 2.
There you go. If it's length 1 or 2, that's the gag condition, or something I have to do more, right? I'm not saying don't do this. This is my thought, right? I can deal with it later. If I'm going to deal with a 1 or 2, that's a deal with it later kind of thing. But right now, I'm maintaining a suite of possibilities. My possible words in all directions for each of these guys. So what I could do then is go through this entire dictionary after I've populated it and say, hey, if you have a 1 or a 2 in it, you are not a possibility. And what that looks like over here is, so this is the basic board that I just made. Let's do this number 13. So I had this printed out. So over here, I made this dictionary. So here I go. So I made my dictionary. And this said, okay, at spot 007, that's a possibility. Over here, that's 3, 4, 3, and 4. So that's good. And 07. So if you look at these, it's 0, 3, 4, 7. That's just off of this logic that has given me these starting space. So, Caleb, sorry, to your question, how did I choose where to start these possibilities in my constraint problem? I said, okay, hey, is this a valid end game? There are lots of ways to start this, but I said, hey, is this a valid end game starting position? Or end crossword position? So I filtered out that dictionary, and this dictionary will be, it made it of this form for each of these guys, right? So it was spot 0, I scanned upwards, I scanned right, I scanned down, scanned who, and then I got 0707. I got each of these as I just described. And then afterwards, I did post-processing. I did that filter condition, right? So let me open up number 12. Oops, sorry. I don't want this. So for this is number 13. So the initial scan of this guy was actually pretty straightforward. I said the maximum word length in any individual spot for each element inside of here was I did the mod the width and I did a subtraction. I just started at the board, right? And then I did the height. I went through, I've got all of these guys. I've got everybody. And then when I want to get down and actually define a possibility, what I can do is I could say something like, hey, only retrieve the possibilities if you do not have a 1 or 2 inside of that list of possibilities. Is that, I've got some nods. Do you want me to repeat that? Do you want me to say this differently? Yes on repeat? Okay. So what I've got here is I'm making a dictionary at the start at board initialization time. At board initialization time, I'm going through with my empty board and I'm saying for every spot inside of here, so for spot 0, I've got 0707 as my list over here because that's in the 4 directions, that's the maximum size that I can get. For 1, it's going to be 1607 because 1607 in these 4 directions that we can go with. So I've got all my directions. And then I do the entire board. Once I'm done going through the board, then I get into the part where I'm processing this game. And before I start determining a possible place where I could actually place this in my constraint set, I'm now going to say, hey, go through this word length thing, go through that dictionary that I just made. And for every single key in that dictionary, for all of my keys, if there is a 1 or a 2 in the value, meaning that if the only size that I have to fit in here is a 1 or a 2, just like don't do that. Let's not do that. Let's not give ourselves problems right now. And yes, Kent.
Just a question. Since one hashtag implies another hashtag flip on the opposite side of the board, within the dictionary, would it make more sense to account for that in the spaces?
So there are definitely optimizations yes, absolutely. Yes. This is, I think, a starting point for me, and I don't mind sharing this code because I'm seeing changes. And honestly, knowing that this board is symmetric as well means that this search probably I don't even need to do the entire board. Like I could probably just do it for half, but yeah. So yes, but in a general, I think maybe not watered down, but in a like hopefully a minimal. I want you to think, use this as a toehold as the answer, as opposed to the answer. Okay, use this as a place to at least think about this as opposed to the answer. Okay, and so then the reality is that once I do this, though, if I make such a move, turns out that this answer is going to change. Like if I play my hashtag right here, what I need to do is reevaluate these possibilities. Because before we knew that this was not like a legit starting place, right? Like this was not an okay place to start looking at this. However, once I place that first hashtag on here, then I can reevaluate my board and I can say, oh, hey, you know what? This guy, not an acceptable location anymore. This guy is an acceptable location. So many of these places that we had at the start remain, but I'm not holding on to that filtered list. I'm holding on to that maximum word length list, and I need to update that maximum word length list. So for my objective at this point is now that I've put this inside of here, I need to look upwards. So your max word length is going to be 3. Your max word length is going to be 2. Your max word length is going to be never mind. That was wrong. You're going to be a 2 above, you're a 1 above, you're a 0 above. That was my logic from before. So this becomes a 2, 1, 0 in that direction, right? Over here, that became a 0, 6 horizontally, and this became a 0, 5, 0, 4. So my point is that in the row and the column, we need to go through and we need to update that maximum word length afterwards. So it's kind of like Sudoku, and that after you make some modification to the board, you need to go back and you need to start updating that possibilities. Because if we're using this as our source of possibilities, we need to now go through and update what these possibilities actually are. I don't know if that helps as a starting point. I think that list, knowing that you have some maximum word length, but then once you place things in, it only works if you're willing to update it. Like if you're not willing to update it, then don't do it. Like that doesn't make sense. Because you need to, as you put these things in here, we need to say, okay, now that I have placed this in there, after placing this, let's go and adjust that maximum word length so that I can run my filter through it next time and like, hey, your 2s, 1s, and 0s, you're off the table. Oh, you're no longer, because I changed your value. You guys are now different options. Yes, Devin.
Okay, so are we placing are you using this method to place like the necessary hashtags to get that number before you start placing words, or do you start placing the hashtag before you start?
Okay, so that's a good question. So the question, so for the recording is like, am I placing hashtags before or after? So the only hashtags I'm willing to put before are my special casing hashtags. So my special casing, if I have like a 10 by 10 board and I've got 10 blocks inside of it, yes, I'm just going to fill that. That feels like a trivial kind of thing where I can just fill it all the way up, print it, return. Yes, question.
But those have their.
Give me 1 second. I'm going to work my way through. That's a good question. So the other, this is my input spec over here. Yeah. So if my main method comes over here, if I've got a number of blocks, I'm not even going to go in and I'm not even going to parse additional arguments. If it's the same, if everything's the same, that's the sort of most trivial case. This is a nuanced one. So if I've got a 15 by 15 board and I have one hole or one block in it, where's that one block going to live? Right smack down in the middle. I don't have options. Okay. So if I know I have an even by even, or sorry, if I have an odd by odd board, it's not even by even, it's an odd by odd board. And I've got an odd number of blocks. You know where that piece is going to be. Put them in the middle. That's the other special casing. And then I go into arguments. So over here, now for arg and arg parsed, I put in all of these arguments. I work my way through the arguments, and then I worry about filling in the blocks afterwards. My placing blocks thing can be broken down into subparts, like this constraint business. We can deal with it later on, but like in the two, but yeah, right now I'm just kind of going through this guy and I'm putting pieces inside of there. So it all seems clear as mud. It all seems straightforward, right? The problem is going to be that the autograder is going to give you conditions which are like kind of not nice. So for example, let's say this. Let's do an 11. Oh, I have to do 15, sorry. Okay. Okay, let's say I've got an 11 by 11 board with the side with a 1 inside of it. The auto grader will give you things that look like you should expect conditions like that. Like it'll say, maybe it'll, and then in addition, and maybe it'll say like 10 or something like this, or 11, right? So here I've got 11 by 11, and then it'll precede these 4 right there, and then maybe it'll say 13 total. So this is where the Johnny on the spot comes in. That is dumped into our wormhole. I have to fill in my constraint things, but my seed conditions have given me something kind of ugly, right? My seed conditions have given me other stuff to worry about. So when I put, and actually in reality, maybe the auto grader just gave me something like this and it said 13. Like that's the kind of stuff you're going to get. All right. Well, right away, I know if I've got these two right here, I also have symmetrically, I have these things to worry about as well. Sure. But when I put those in, what have I created over there? I've created ones. So my logic is that every time this is basically my breakdown of my system right now. I handle every single thing. I place a block, I put that block down, or sorry, I'm going to say place hash. I'm going to update the maximum word length. I'm going to go through, maybe it feels maybe it feels inefficient, but I'm going to update that maximum word length thing over there. What I also am going to do is I'm going to look to see after I've updated that maximum word length if I have created badness region, for lack of a better term, right? So I've got a badness region right there. And so if I've created a badness region, I need to create a queue of other things to do. Like placing one block is not just placing one block anymore. Like placing one block could mean placing lots of blocks. It could mean placing 4 blocks. Like it could be something horrible, right? Where if I get a placement, if I have a block placed right here, for example, if I have a block placed right here, like that's gonna mean filling in all of this corner. I have to do all of these things. So I only got the spec to do this little guy right there, but the reality is I have a lot to do. So when I place a hash in, I'm going to update. And every time I go in and have this hash to update, I start out by making myself a queue. And I take that first value and I plunk them into the queue. And I'm like, okay, this is my queue. This is my queue of things to do. He becomes my to-do list. He's first on the to-do list. And the to-do list is going to say, put your hash in there. Okay. The first thing in the to-do list, the first thing in the queue is not necessarily going to be anything else. The first thing in the queue is going to be his symmetric buddy. So as soon as I put him in there, if he has a symmetric buddy, he's getting his symmetric buddy that also goes in there. So boom, that's going into the queue. And then for each placement, I'm going to place this guy. And when I place it, I'm going to put that guy down. I'm going to update everything around him. And then I'm going to evaluate the spots around him that I might have just screwed up. And as I evaluate, hey, you know what? I put you in here. I put your neighbor in here. And I'm going to update and evaluate. So guess what? You just got 2 more in the queue. And then I'm going to evaluate in this direction. Boom, boom. And then you just got 2 more in the queue. So putting that first thing into there, this one function called to place one hash has given me 5 pieces to place. Okay. So one call, this is before anything else. So when I place a hashtag, my logic is really kind of involved at this point. So this is not anything to do with placing blocks. So my placing blocks method is invoking placing a hash, but placing a hash is going to be a big deal. So what does it look like? Where do I find my definition for this? Give me a definition, bud. This is 16. Sure. My place a hash. So oops. Here's my place hash. So I start with my source location where I'm supposed to place this hash, right? This is where I've got to put this thing. I'm going to make myself a queue. It's just going to be a list. These are the things that I need to deal with. Here are all the places that I'm going to update by the time this place hash is over. I could do it recursively, but I think that's slow. Let's just do it iteratively. I'm popping 0. This feels slow. So there's room for optimization, but I pop 0 inside of here. I kind of say, hey, if the this is my own maintenance of that possibilities dictionary. So what my question here is basically saying, if you don't already have a hashtag in, right? If you are not already, if this spot is unfilled, because I'm not going to treat the spot if he's already filled. If there's something already there, I can just stop. So if there's something there, then don't do it. But what I'm going to do is I'm going to put my hashtags inside of here. Okay, well then the first thing I'm going to start doing is I'm going to say, hey, if the spot on the right, if I only had certain things, this is a little bit backwards logic over here, but basically the logic is saying, hey, you know what? These are the maximum size words that I can stick into here. And these are, this is backwards. Don't look at this for like thinking this is working. Okay. But it's this iterative approach of how much space do I have inside of here? Okay. Let's update how much space I have inside of here. Can I fit other things inside of here? If this is a spot that only has 2 spots available for it, you're out the door. Can't do it. You're going to get filled in. You get added to the queue. If you are a short place, you get added to the queue. So the very process, whenever I want to put a block in here. So for example, when I have my initial, call to assigning words, when I'm assigning words, if it's a hashtag that I put inside of here, I'm going to call place the hashtag. Place that hashtag in, he's going to do all his business. He's like, oh, you've got an inversion, you've got a 180. Okay, we're doing that. All right, let's update these possibilities. Do you have a short stack above you? Oh, guess what? We're going to do those while we're at it. We're going to resolve all of our problems. If you put a hashtag in there, just like resolve your problems of that hashtag. This lends itself, it's still not perfect, but at least lends itself to like a way to get hashtags inside of there in such a way that like you can, this will, oh, a 16 by 16. There we go. So the auto grader, this hash resolution input parsing, right? Like the input parsing, I had a spec here for a 2x4, right? Vertical 2x4. 2x4. Row 2, column 4. That guy. So 2x4, I resolved these things. I resolved those things in that stack over here. 4x5. So we start getting all this other stuff. Now, these are blocked regions. That's a whole nother layer to this crypt that you're going to have to like get into. But you can at least worry about resolving these conflicts that are definitely going to be placed inside of there. Figure out. Because there's no way, if I put this right here, I can't have words above it, so I need to fill upwards. If I put that right here, I can't have words to the left of that, so I need to fill inwards. And I can't have blocking regions. So this is going to be my thing that goes in. This is probably going to need to be filled in. I've got a word that goes in here. This is contiguous. This is not. So that's a story for a later day. My workflow. You want to see my workflow one last time? Here's my workflow. I need to let you. My workflow is as follows. Deal with special casing. If I have a 10 by 10 or whatever like that, fill it in. If you have a spot in the center, put that spot in the center in. Then go through the arguments and then worry about your constraint problem. Okay? That's the top level. Special casing, do the center, do the arguments, do the constraint. When you're doing the arguments, go through here. When you're doing the arguments, as you place hashes, resolve problems. As you place hashes, resolve problems that they introduce. Whenever you place a hash, resolve the problems that hash introduces. Okay? So, to repeat with elaboration, special casing, do the center, do the arguments, but as these arguments are being filled in, if any placement of a block creates a bad area, resolve that bad area as you put the block in. Don't save it for later. Resolve the stuff that is bad as you encounter bad, which means you need to be maintaining some sort of board state coming out of here. Rocking and rolling. Then we're going to go through and get to these constraints. The constraints work out pretty normally. It's kind of not so bad if you AV for word. Yeah, so here we go. So I have my array of possibilities. My array of possibilities is derived from knowing, is this going to be a maximum word length? Is this a problem word? So it's that array. I go through, I look through that array and say, hey, here are my possibilities. I'm going to go through, you guys. And then as I go through, I'm going to place a block. Every time I place a block, though, I need to resolve problems. I feel like I'm just, I don't know. I'm sorry. And as you resolve the problems, then we need to check if the board is actually valid. The board check of the valid becomes the BFS. Rocking and rolling. I don't want you to check out, and I feel bad spending 45 minutes talking when I can be helping you. But like, I also think that you need to have a game plan with this. And if you don't have a game plan, it's just going to be crazy. My game plan, hopefully this is enough organization. I think figuring out the maximum word length is a good place to start. If you have a BFS and a working constraint set, that's figuring out the maximum word length that you can fit in there is going to be the first tone. We'll take as much time as we need to make this happen. I'm not like, don't this,